things never change. We should understand that chemical changes produce new substances. That mass and matter are conserved in the chemical reaction. We should be able to calculate mass loss in a reaction and predict what happens to mass in a reaction based on an equation, a balanced chemical equation that we talked about last class. So, a chemical reaction.
Okay, we wrote this down, right?
Wait, did we already do this?
Yeah, come on, Kelly. Oh.
No, we didn't. Okay. So, chemical reactions, you guys don't have to take this down. What you have to do is take down the second point.
Atoms, that one?
Yep. So, this is a review, partially. A chemical reaction is a rearrangement of atoms. The atoms are not created nor destroyed. And that's called the law of conservation of matter or conservation of mass. So, they just arrange themselves differently before and after. New substances are created. Here's some modeling of chemical reactions. You don't have to copy this down. Just look up here. So the different particles represent the different atoms. So in a chemical reaction, we have the same number of atoms of each on both the products and the reactants. So the atoms are just rearranged. And that's why we have the same mass and same number of atoms. Okay? So in a chemical reaction here, Christian, can you look up here, please? Thank you. Nick, what are you doing? Okay. Pay attention. So in a chemical reaction, we have two Na particles react with one Cl2 particle, and we form two NaCl. So if we start with 46 grams of sodium and we react it with 71 grams of chlorine, we would expect to get 117 grams of sodium chloride. The mass of the products is equal to the total mass of the reactants. Okay? So you guys want to copy this down?
All of it?
Yep. So the key thing here, guys, is that the total mass of the reactants is equal to the total mass of the products. So in this case, if we started off with 71 grams of chlorine gas, look up here, and 46 grams of sodium metal, after it reacted, I would expect the total mass to be 117 grams. Because I have the chlorine gas, which has mass, reacting with the sodium metal here. After it all reacts and it finishes reacting, the mass should be more. Okay?
Wait, what are we reacting
with? The chlorine, this is 71 grams of chlorine gas. Chlorine gas is a greenish colored gas.
Oh, like with what? Oh, we're putting gas in it?
Yeah, so this chamber is full of gas. And this is
I thought it was a cup.
and this is a cup with sodium metal in it.
Oh, wait, what?
Sodium, it's representing this reaction here. This reaction here. Na2Na plus Cl2 makes 2 NaCl.
So how many?
So assume the chlorine gas is inside the chamber, 71 grams of it.
Oh, we're not doing it. You're just it's an example.
Yeah, it's just an example.
Oh, okay.
So-
Like, isn't the gas gonna like fly everywhere?
Yeah. Well, it would be that's why I sealed it in here. But here's an example for you guys. So say we react 6.35 grams of copper with oxygen from the air. And we ended up with 7.95 grams of copper 2 oxide. How much oxygen did we react? We can actually figure that out. Because exactly. We know that the oxygen that was in copper oxide came from the atmosphere.
1.60?
So, yeah. So if I started with 6.35 grams of copper, I ended with 7.995 grams of copper oxide. You can set it up like an algebraic equation, or just subtract what you ended up with from what you started, and you end up with 1.6 grams of oxygen. Does that make sense? Yeah. So the total mass of the products has to equal the total mass of the reactants. So here's one where I want you guys to try out. Okay? I want you guys to try this out for a second. Write this down in your notes, and this will be like a... So here, I'm giving that I'm starting off, let's say I had a balance right here with a sample of calcium carbonate. And the balance, this is the balance. The balance read 20.0 grams. And then I reacted it, and that's CaCO3. Then I reacted, I heated up, and I measured the mass again. The mass, again, at the end of it, after I measured it, it was a different substance, and it measured 15.8 grams of calcium oxide. So what was left over? How much CO2 gas escaped?
1.2.
4.2. I started off with 20. I ended up with 4.2 grams of carbon dioxide escaping into the atmosphere.
Did you just find the difference between them, Achilles?
Yep, we found the difference between. Yep, we just subtract them, and that's how we find it. You can draw whatever's useful for you.